Hi, welcome to our webinar for CASTDDoS product. Today we are going to talk about the emerging DDoS landscape, how it is growing, how it becomes challenging for the companies. So before we start, next please. So today we are gonna again talk about the DDoS, and at the moment, what we see is in the last couple of years, DDoS attacks emerging quite aggressively. There are several reasons of that. One of them is geopolitical conflict, acceleration. Pandemic accelerated digital transformation and AI-driven threats. These are what we see for the last almost 4.5 years, 5 years. Plus, the IoT devices, unsecure IoT devices also contribute a lot to this landscape. And today, maybe 5 years ago, we are talking about once a year vulnerability check. Today's landscape is unfortunately almost impossible. You have to do it very frequently, not only one vertical, but all the technological vertical that your system uses. So that's pretty important that you have to do the periodic vulnerability scan and so on. Next, please. So today, as you can see in the graph on the left side, from 2010 to 2014, 2010 to 2024, end of 24, you see an exponential growth of DDoS attacks. From almost kilobit per second from 2010, now we are talking about terabits of traffic. This is becoming quite disruptive for IT infrastructure or IT infrastructure owner. So the growth almost more than 100+% every quarter. If you look at all the cloud providers post or their website, you see that there is exponential growth. This growth specifically targeting primarily financial institutions and then critical infrastructure like transport, telecom, healthcare, and so on. You even can see some of the big tech companies like X can receive DDoS attacks, and this is becoming quite almost usual for the IT owners. Besides that, what we see is we also see a regulatory perspective. Regulatory bodies start putting some rules for example, for banks. We see it in Europe and US primarily, but we expect that rest of the world, if they haven't, they will start putting some regulation as well. Next, please. One of the interesting part what we see in our field test is or field experiences, maybe 10, 15 years ago, IT infrastructures are pretty straightforward and simple. Now it's becoming very sophisticated, and it is managed by different teams or different companies even. That brings also additional layer of complexity to the landscape. And what we see is some of our customers, big names, they do buy these mitigation services from their supplier, but they haven't updated their configuration or their setup, which becomes these services basically vulnerable to the attack vectors and so on. So what we bring as a solution or vendor, we bring a continuous test to the customer infrastructure. But next, please. So what we do is basically we simulate the DDoS attacks either ad hoc or periodically, depends on the customer requirement. These simulations, we call them simulations because they are high capacity, almost real world simulations. The only difference is we stop after a certain time, or we stop based on the customer predefined thresholds. We do this tests almost last 5 years, beginning of 2022. We have a pretty good experience in that area, and we are now, as a next step, we are bringing all these experience and technology to the MSPs and enterprise product owners. Any questions so far? Okay, great. What I will do is I would like to show you our platform quickly as a demo. So basically, our platform is, let me share my screen first. So our platform, this is an in-house built platform. We develop everything from top down, bottom up. And in a nutshell, it's pretty straight to use. Basically, what we do is we put the IP address or the URL of the system with the port information. In this case, we just use 20 bots, and we do UDP floats for like maybe 100 meg of traffic for 60 seconds, and we see that we will do two tests. We see how the system works. The minute you submit the form, the system take the attack into the queue and start the preparation. We have a basic countdown timer where it basically shows you whether the attack started or when it will start. You see the metadata of the attack where the unique ID, test vector, type, status of the attack, target system address, monitoring address, port, bandwidth information, start time, the preset duration, how many bots we will use, and in some cases, if you would like to do the ramp up, basically you can gradually increase the traffic. As of now, by default, we don't activate this feature, but it's possible to activate. Once the test starts, the system starts basically monitoring the remote ends for 10 to 15 seconds to verify that the remote system is active and working. Once it's active and working, as you can see, we start pushing the traffic. For these purposes, as we predefined, we have 100 meg of traffic at the moment in this network. And we will continue pushing this traffic for 60 seconds, and then we drop the traffic after that. As a part of the real monitoring, we monitor the remote system with HTTP response time, response code, and we also present this as a time series chart in front of the customer that gives the customer the whole view of from the beginning to end of the test, what has been done or what is going on. When the test finishes, the system automatically redirect you to the what we call these offline reports. At the moment, what you see is live reports. This is limited. When we move to the offline, you will have more information as a customer. So again, like once we finish the test, the system basically redirect us to the offline report. Offline report, we see all the metadata from the live report. Plus, we have the end time, running time, actual running time, plus the metrics or KPIs for the test. So for this test, we monitor the availability, packet loss, and response times, and it gives us quantified information about whether the remote system has or the attack has any impact to the remote system or not. When we go down, we can also see summary of what has been done or what our system sees, and also the distribution of the sources, the source traffic towards the attack. So for this test, we basically, our system is in Belgium. So Belgium is the red one and the blue ones are the source. We also break down the source location of the system with the, again, HTTP health monitoring, network layer, the TCP layer, whether there is any packet loss or not, and standard network traffic monitoring, such as packet per second and bandwidth per second. That's pretty much it is what we have. What I would like to do is we have another test setup for this. This is what we basically do here is to send volumetric traffic. We also would like to do another test for these purposes, which we will run again 20 bots with this time it will be a TCP attack, and you will see the real difference about what has been done or what is happening to the remote system. Again, once we submit the test, the system start counting down. We also have any given time, we also have the ability to stop the attack with the emergency stop. If the customer system requires to stop the test, we can immediately stop the test from the emergency stop. Again, we start monitoring before the test starts. And then once the test traffic, again, as you can see, once the traffic, we start pushing the traffic, the remote system becomes unavailable. So the reason why I did or we did two tests is to present how effective it can be in systems where you don't have the mitigation and so on. The system also presents you a visual graph where you, as you can see, from 0 to 5 seconds, we split the graph into 4 different categories from green to red. Red means that the system becomes unavailable, and or towards the red or towards the 5 second, the system or the graph color changes from green to red. And also present us what are the actual response time what we receive from the remote system. And again, once we finish the test, the system will redirect us to the offline reporting. And once we have the offline reporting, the difference this time is, as you can see, the availability compared to the previous test. So this time, availability is very poor. And what we can do is we can actually look at it from here, where you can see that availability based on this criteria, how we define the availability and what it looks like. Same with the packet loss and the response times as well. Again, same distribution where it comes from, application layer, monitoring, and so on. Actually, that's pretty much it is what we would like to present you today. Any question from anyone so far? Okay, thank you very much for your time. Have a great day. And if you have any question, please do not hesitate to contact us via support@safe-co.uk or hadi@safe-co.uk. Thank you very much.